Good morning. Today we will continue with some from miscellaneous exercise. So 11th one, sum number 6, prove the following. Cos 2a upon a square minus cos 2b upon b square is 1 upon a square minus 1 upon b square. Begin with LHS. So it is 1 upon a square. What is cos 2 theta? Cos 2 theta is 1 minus 2 sine square theta. Use that. Now open the bracket. I have omitted one step. So this is 1 upon a square minus 1 upon a square sine square a minus 1 upon b square plus, in fact, 2 upon, not 1 upon, 2 upon b square sine square b. So I have written this as 1 upon a square minus 1 upon b square. Take minus 2 common. So it will be sine square a upon a square. As I have taken minus 2 common, again it is in bracket minus sine square b upon b square. Next part is simple. I will directly write this as 1 upon a square minus 1 upon b square minus 2 times 0. Reason, by sine rule, sine a upon a is nothing but sine b upon b, right? Therefore, sine square a upon a square minus sine square b upon b square is nothing but 0. So this is simply 1 upon a square minus 1 upon b square, which is nothing but right hand side. Seventh, prove that b minus c upon a equal to tan of b by 2 minus tan of c by 2 upon tan of b by 2 plus tan of c by 2. We begin with RHS. Tan of b by 2 minus tan of c by 2 upon tan of b by 2 plus tan of c by 2. Some students may think of componendo dividendo or dividendo componendo, but remember, componendo dividendo is to be obtained not on ratio but on proportion, right? So begin with RHS. Now use half angle formulae. So what is tan b by 2? Root of s minus c s minus a upon s into s minus b. Similarly, write for tan c by 2. Now simplify, because LCM is root of s into s minus b. So this becomes s minus c. I'm sorry, LCM is root of s into s minus b into s minus c. So this becomes s minus c root s minus a minus s minus b root s minus a upon s minus c root s minus a plus s minus b root s minus a. Root s minus a is not equal to 0. So cancel that to get this s minus c minus s plus b upon s minus c plus s minus b. So what remains is b minus c upon 2s minus in bracket b plus c. But what is 2s? Perimeter of triangle, sum of the lengths of all three sides, that is a plus b plus c. So it is b minus c upon a plus b plus c minus in bracket b plus c. Open the brackets to get b minus c upon a, which is nothing but left hand side. You may ask me, can we begin with LHS? Yes, we can, but this is comparatively simple one. Begin with RHS. In that case, we'll have to use sine rule. Then angle A is pi minus b plus c and so on, because on the right hand side, we do not require angle A and so on. But why not to go for this? Sum number 13, in triangle ABC, if angle C equal to 90 degrees, then prove that sine of A minus B is A square minus B square upon A square plus B square. Actually, this can be solved using different methods. You may say, can we begin with RHS? Yes, you can. But here I have begun with LHS. First, draw the diagram. Major angle C is 90 degrees. So by Pythagoras theorem, what is C square? It is A square plus B square. Not only that, here we should write that what is sine A? Sine A is nothing but opposite side upon hypotenuse, that is A upon C. And what is sine B? Sine B is nothing but opposite side B upon hypotenuse C. We are going to use this also. Begin with LHS. Sine of A minus B, sine A cos B minus cos A sine B. Replace sine A by C and replace sine B, not cos A, sine B by B upon C cos A. After that, I have used cosine rule. See, reasons are to be mentioned, otherwise you won't get marks for that. Here you have to say using cosine rule. So 2c square is nothing but LCM, because here A gets cancelled and here B gets cancelled. So 2c square is nothing but LCM. So A square plus C square minus B square I hope you are getting this. Is that correct? So numerator is a square plus c square minus b square, minus sign is there. So minus b square minus c square plus a square. So twice in bracket a square minus b square upon 2 into what is c square? A square plus b square, right? So it is a square minus b square upon a square plus b square, which is nothing but right hand side. Actually, after sine of a minus b equal to sine a cos b minus cos a sine b, you may also say from triangle, see, from the triangle, what is sine a? Sine a is nothing but a upon c. What is cos a? B upon c. What is sine b? B upon c. What is cos b? It is a upon c. So if you substitute the values, you get a square minus b square upon c square. But what is c square? A square plus b square. But I will suggest better you use cosine rule. If I were the paper checker, I would have given full marks for this. But still, don't take a risk. Use cosine rule only. But this method is absolutely right. Sum number 12 now. Just listen to me. You have to write the solution after the lecture. In triangle ABC, if ABC are in arithmetic progression, then show that cot A by 2, cot B by 2, cot C by 2 are also in AP. See, question is modified. You will find uh, different, slightly different question in the textbook. Now this is the correct version. I read the sum again. In triangle ABC, if small ABC are in arithmetic progression, then show that cot A by 2, cot B by 2, cot C by 2 are also in arithmetic progression. Now ABC are in arithmetic progression. So 2B is A plus C. Now cot A by 2 plus cot C by 2. Cot is cos by sine and so on. So you get sine of A by 2 plus C by 2 upon sine A by 2 sine C by 2. Now a plus b plus c is pi. See, this is the reason. So it is a by 2 plus c by 2. It is pi by 2 minus b by 2. Sine of 90 minus theta is cos theta. So this is numerator. In the denominator, I have used half angle formulae. So it is sine a by 2. Root of s minus b s minus c by bc. Sine c by 2 is root of s minus a s minus b upon ab. Simplify to get cos b by 2 upon s minus b upon b into this. But note that this part, root of s minus c by ca, is nothing but sine b by 2. I hope you are getting this. So this is b upon s minus b, cot b by 2. Right? Now, next part is important. S is nothing but semi-perimeter. So can I replace S by A plus B plus C upon 2? Yes, I can. So if you do so, you get 2b upon 2b minus b. That is just b cot b by 2. Okay, because from 1, see, a, b, c are in arithmetic progression. So a plus c can be replaced by this. So what I get is just 2 cot b by 2. Means cot a by 2 plus cot c by 2 is twice cot b by 2. When does this happen? This happens when cot a by 2, cot b by 2, cot c by 2 are in arithmetic progression. And we are asked to prove this only. 14th, in triangle ABC, if cos A upon A is cos B upon B, then show that it is an isosceles triangle. Actually, we already solved this sum. The only change was we were given A cos B is B cos A. So can you solve this? So cos A upon A equal to cos B upon B becomes A cos B equal to B cos A. Actually, don't write this directly. Say that by sine rule, A upon sine A equal to B upon sine B equal to C upon sine C. And then you have to say that replace small a by k sine A and small b by k sine B. Okay. So it gives me sine A cos B as cos rather minus cos A sine B equal to 0. But this is expansion of sine of A minus B. So sine of A minus B equal to 0, but sine 0 is 0. So A minus B equal to 0, that is A equal to B. So triangle is isosceles. See, the correct sum is in triangle ABC if sine square A plus sine square B is sine square C, not sine 2A or sine 2B. Sine square A plus sine square B plus sine square C, then show that triangle is right angled. Now by sine rule, sine A by A is sine B by sine C by C, which is K, say. So sine A is AK, sine B is BK, sine C is CK. Substitute to get a square plus b square equal to c square. This happens only in right angle triangle, converse of Pythagoras. So we have to say that triangle is right angled at C. Sum number 16. I'll explain the solution. You have to write it after the lecture. In triangle ABC, prove that a square cos square b minus cos square c plus b square cos square c minus cos square a plus c square cos square a minus cos square b equal to 0. Actually, you will notice that from first, second and third terms can be written just by making cyclic changes. So it is sufficient to simplify only one, and then you can say by making cyclic changes and so on. But in this solution, they have considered all the terms. That is also correct. By sine rule, A by sine A is B by sine B, C by sine C is K. So A is K sine A, B is K sine B, C is K sine C. Begin with LHS. So that is, I'm considering first part. So K square sine square A. Now what is cos square B? 1 minus sine square B. What is cos square C? 1 minus sine square C. Rearrange the terms to get this. Now next part is simple. They have opened all the brackets, have taken k square common to get what? Sine square A sine square C minus sine square A sine square B plus sine square A sine square B minus sine square B sine square C plus sine square B sine square C minus sine square A sine square C. So all these terms get cancelled. What remains is k square into 0, which is 0, which is nothing but right hand side. I'll explain once again. See why sine rule is to be used, so that a square can be replaced by k square sine square A, b square by k square sine square B, c square by k square sine square C. Now you may think of using cosine rule. Don't use that, because cos b itself is a square plus c square and so on, and it is cos square b. So replace cos square by 1 minus sine square and just open the brackets by taking k square common to get required answer. 17th, with the usual notations, show that c square minus a square plus b square tan a equal to a square minus b square plus c square tan b equal to b square minus c square plus a square tan c. Now c square minus a square plus b square sin a upon cos a, because tan is sin a by cos a. Now use both sine and cosine rules so that sin a can be replaced by ak. And what is cos a? B square plus c square minus a square upon 2bc. So c square minus a square plus b square tan a becomes twice bc ak. This is number one. Now make cyclic changes. You will notice that left hand side changes. For example, next change will be b square, rather a square minus b square plus c square tan b. Will right hand side change? No. It will be 2c abk, same as twice bcak, and so on. So by making cyclic changes, you get second and third result. So from 1, 2 and 3, please do not write like this. You have to write that from 1 to 3, c square minus a square plus b square tan a, and so on. Sum number 18, this is an interesting sum. In triangle ABC, if a cos square c by 2 plus c cos square a by 2 is 3b by 2, then prove that ABC are in arithmetic progression. Now, what is cos square theta? It is 1 plus cos 2 theta upon 2. See, formula for cos 2 theta is 2 cos square theta minus 1. So, cos square theta is 1 plus cos 2 theta upon 2. So, 2 times c by 2 is c. Please do not write 1 plus cos of c by 2. It is 1 plus cos c upon 2. Similarly, what is cos square a by 2? 1 plus cos a upon 2. 2 gets cancelled. Now open the brackets to get a plus a cos c plus c cos a equal to 3b. Now, what is a cos c plus c cos a? By projection rule, it is b. So we get a plus c plus b equal to 3b. So a plus c equal to 2b. At this stage only you can say that a, b, c are in AP. But it is better if you say rearranging the terms to get c minus b equal to b minus a. As the difference between two consecutive terms is constant, the terms are in arithmetic progression. 19th sum, show that 2 sin inverse 3 by 5 is tan inverse 24 by 7. Now we have formula for tan inverse P plus tan inverse Q, right? So why not to express sin inverse in terms of tan inverse? Begin with, let sin inverse 3 by 5 be alpha. So sin alpha is 3 by 5. Now for sin inverse, what is the range? Closed interval minus pi by 2 to pi by 2. But as sin alpha is positive, alpha has to lie between 0 and pi by 2. So that tan alpha will be positive. Now you may say from sin alpha using fundamental identity, we will obtain cos. Yes, that is absolutely right. But if you construct the triangle, you get tan alpha directly. Opposite upon adjacent. So what is alpha? Tan inverse 3 by 4. So 2 sin inverse 3 by 5 is 2 tan inverse 3 by 4. Now it is 2 tan inverse 3 by 4. Tan inverse 3 by 4 plus tan inverse 3 by 4. So tan inverse P plus Q upon 1 minus PQ. So that gives me, on simplification, I have multiplied each term by 16. And therefore I get 12 plus 12 upon 16 minus 9. So tan inverse 24 by 7. Sum number 20, show that tan inverse 1 by 5 plus tan inverse 1 by 7 plus tan inverse 1 by 3 plus tan inverse 1 by 8 is pi by 4. We divide these four terms into two groups. Now apply tan inverse P plus tan inverse Q equal to tan inverse P plus Q upon 1 minus PQ formula. See what you get. So this is tan inverse. Multiply through it by 35. So 7 plus 5 upon 35 minus 1. And here tan inverse, if I multiply by 24, 8 plus 3 upon 24 minus 1. So this becomes tan inverse 6 by 17 plus tan inverse 11 by 23. Now again same thing, tan inverse P plus tan inverse Q is tan inverse P plus Q upon 1 minus PQ. On simplifying you get tan inverse 1, which is pi by 4. 21st, prove that tan inverse root x equal to half cos inverse 1 minus x upon 1 plus x. Now we begin with let tan inverse root x be y. So root x is tan y. So x is tan square y. What is right hand side? Half cos inverse 1 minus x by 1 plus x. So half cos inverse 1 minus tan square y upon 1 plus tan square y. That is half cos inverse cos 2y. Cos inverse cos 2y is 2y. Half into 2y is y. But what is y? Tan inverse root x, which is nothing but left hand side. uh, 22nd, yes, we will be solving that, but in the next lecture. First we discuss sum number 23. Show that tan inverse root of 1 plus x minus root of 1 minus x upon root of 1 plus x plus root of 1 minus x is pi by 4 minus half cos inverse x for minus 1 by root 2 less than or equal to x less than or equal to 1. Begin with LHS. We put x equal to cos theta. So what is theta? Theta is nothing but cos inverse x. Now LHS equal to 1 plus cos theta is 2 cos square theta by 2. 1 minus cos theta is 2 sin square theta by 2. Simplify. See, we have done this part at least 2 to 3 times. So what remains is this. Now divide numerator and denominator by root 2 cos theta by 2. So what we get is 1 minus tan theta by 2 upon 1 plus tan theta by 2. Now this one can be replaced by tan pi by 4, so that it takes which form? Tan alpha minus tan beta upon 1 plus tan alpha tan beta, which is expansion of tan of alpha minus beta. So this, see the cursor, this can be replaced by tan of pi by 4 minus theta by 2. Now tan inverse of tan of any angle is that angle. So pi by 4 minus theta by 2. But what is theta? Cos inverse x. So we get pi by 4 minus theta by 2 means minus half into theta. But theta is to be replaced by cos inverse x, which is nothing but right hand side. So that's it for today.